Alright guys, me Elf Gaming, and I'm back with some more like technical stuff. I have a dead CFL. This is like one of the last one existing in my home. I went on and used some force or the force or a force of sort and opened it. It didn't want to come lightly. This light failed last night, so alright, we're gonna see it. But I also brought out my other, this one, and we're going to look at the voltage on that. We have one AAA Chinese rechargeable. Put it in and it lights, and show that that is a Chinese battery. 1.15 volts as it's running down. We are getting at about 582 volts AC coming out of that. You don't want to be grabbing that. It is very low current, but I'm assuming that it would still make you feel it. And I'm running this off of a camera flash circuit. These leads here, this one are going to the bulb. These two are from battery. Took out the little flyback transformer. Took out the big capacitor. They're not needed. And it'll run that bulb very, somewhat. I mean, if it's dark, you can see it. So we're going to open this. But first, there's a diagram of what I can make of what I've done. It's coming in, primary winding, that's a transistor. Power from here. It's interesting how this works. If you can make any sense of that. I mean, I can, but I am horrible at explaining this. I know there's a feedback circuit, and it's driving. That's the neon circuit. It's not being used, but it's there. Bulb is coming off of this winding. Our feedback is this winding here. So it's primary, secondary, and this is your feedback circuitry all here. Typical flyback circuit. You're getting about 600 volts, anywhere from 5 to 700 volts off of this, maybe more if there's more power coming in off of 1.5, but the current is very, very low here. You'll probably feel it, but I'm not going to test that theory. So we're going to open up this one. These types can be made into running off of that low volt. I mean, that should come right off of there, but it's not wanting to. I may have to use the force on that or get down in here, just break them loose. I'm not going to use this bulb anymore. Like I said, it died on the socket. Whoop. Well, okay. Oh, there it is. There it is. Power transformer. And these bulbs are fired a little differently. Not one-to-one like I had that one hooked up. When these tied together. These actually have 4 legs that they tie onto respectively. And the center has a capacitor. This one and this one has a capacitor across it. Where our AC is coming in, this right here and right there. And it's hitting a common mode choke, of course. And it does have this rectifier in it. These are capacitor dropping. We are dropping with this capacitor, this green one, this little thin mint looking thing, green one, and we got 1, 2, 3, 5 diodes here, 2 transistors, 6 diodes. There's another diode in there. And 2 transistors, 6 diodes, 1 choke, 1 transformer, 1 electrolytic, 1, 2, 3, 4, 5 films, and another coil. And then we have some discrete surface mount resistors back here of 47 ohms, 100 ohms, and whatnot there, with some modification. And I'm not really sure how to do this. We're just looking inside this, by the way. I'm not modifying anything, but I think this bulb is still good. And what I want to do is connect this bulb onto the little thing that I had built or modified, the camera flasher circuit that I modified over here. I want to see if this bulb is in better shape than the bulb I have currently on there. See, when the power goes out, instead of burning my solar power up on lights in my bathroom, I have this hung up over the shower rod. Because I'm not taking a shower in the dark. I mean, I do it in the daytime. And that little battery, little rechargeable battery, will run that light whenever I need it. You know, I turn it on and off, take the battery, put it in and out of the deal as needed. It doesn't stay in there all the time and be wasting light, electricity. But if this bulb is in better shape, I can get it off the stake. I had a bunch of these CFLs at one time, different wattages. I still have a few still working around the house. Why change them if they're not out yet? But I've gone mostly LED. But I don't throw these in the garbage. I save them because they're reusable. I mean, even the parts that are in the base could still be good, even though this one's shown signs of obviously heating. This bulb here is looking like it has seen better days. It's got some blackening on it starting to form. Also, this is a bigger bulb here. So we're going to tie it on. I'll worry about soldering it later. We want to see if it works, if it will strike, you know, what the luminosity looks like on it. When it was working, it was like really bright. I don't think the bulb has gone bad. I think it's the circuitry that's gone bad somewhere. We'll just tie it in place, and we'll put the battery back on this, and hopefully it won't smoke. Alright, so yeah, there it is. Oh, it's bright too. Definitely a reading light. I mean, it could be brighter, but you know, my battery is kind of going dead here. I've got another one. It's a AA. I'd have to improvise it on here. But you can see how this, well, it's weird. It's not want to stay up. There it goes. A lot brighter. Yeah, a lot brighter. Definitely a reading light. You can imagine if it's pitch black somewhere that this would just illuminate the room completely. Like, I mean, you wouldn't be able to like do any surgery under it or anything, but yeah, one AAA battery. By the way, this is a Fuji camera flash module that I had modified to stay in constant charge mode. I took the big capacitor out and the firing switch is shorted. Yeah, if you know how to modify these little boards, you can run one of these off of one of these. So, and I tried to reverse engineer it, and this is what I've come up with, this diagram. I don't know how correct that is. Trying to do this is it's interesting. But anyway, that's it. And this is the inside of a CFL. This is the ballast, the driver, whatever you want to call it. This is going to be used for parts. I'm going to go through, I've got a capacitor meter. I'll check all these capacitors and everything See what's good and what's not. Put it in the parts bin. Stuff like this. There is a fusible resistor in here, like 100 ohms or 10 ohms or something. But this here wouldn't be any good for anything anymore. I'll try to get that out, that resistor out of there without tearing it apart. Would be nice. I could just desolder it from the base. Well, anyway, that's all I got for now, and I'll see you guys in the next video.